Suppose you're a programmer in the business of web development. You will not just create web pages, but you will also create a database of all the products sold by the business people and also manage them. You must create a database of all the products behind the web page itself so that customers can easily find the products they are looking for. If you had used websites like Amazon and Flipkart to buy items, then you will know how it is. The item you want to purchase, you will type it on top and then it will come up as a list of items. The items that are listed have already been entered into the database by the programmers. In this application design, the most important role is played by the database design. If the programmer doesn't design the database properly, then it will be really hard for them to design the whole web page. But not just that, the website on the customer side will also work very slowly. So each group in the database table will be called a set. You may now understand how important it is for a web developer to know the concept of set theory. Now, let us learn what a set is. Set is a collection. If a collection of items or numbers have a common property among them, then they can be grouped into a set. For example, Sony, LG, Samsung can be grouped into a set as they have a common property to manufacture TV. The elements in a set can be rearranged in any order, but the elements in a set cannot be repeated. For example, let us suppose you have a pouch and in that pouch there are 2 pens, 1 pencil and an eraser. When someone asks you what's in that pouch, you will tell them that you have pens, pencil and an eraser. But you will surely not tell them that you have a pen, a pencil, an eraser and another pen, right? So 1, 2 and 3 and so on will be called a numerical set. The property these numbers have in common is that they are all natural numbers. Each number in a set will be called an element of that set. The elements are separated by commas, covered by curly braces on both ends of the set. The 3 dots are called ellipses. Ellipses denotes that not just 1, 2 and 3, but the numbers in that set keeps going on. The list of elements is called a listing form or roster form or tabular form. Now, are there any other way to represent a set? Yes. In fact, there are 2 more ways. One is a set builder and the other is Venn diagram. Here also, we are using curly braces to create a set, but on the inside, instead of listing all the elements, we will use a variable and a condition related to the variable to represent the set. For example, the set n can be written as above and will be read as the set of all x such that x is a natural number. If there are more than one condition, then we will separate them using commas. We will use colon or a vertical line to denote the term such that. In a Venn diagram, we draw a circle and write the elements inside it. Your math book will say that a set is a well-defined group of objects. Here the term well-defined means that the elements will be different from each other. Suppose I ask a class of students what their favorite sport is. The answer will be different with respect to each person. So a set is supposed to be well-defined. So the set of all natural numbers is well-defined because they are all different from each other. So from these 2 examples, we see that based on the number of elements, the set can be either a finite set or an infinite set. Suppose we have the following sets. The number of elements of set A will be denoted by n of A and the number of elements in set B will be denoted as n of B. If there is just one element in a set, we call it a singleton set. If the cardinal number of sets A and C are equal, that is, the number of elements of A and number of elements of C are equal, then we call them equivalent sets. And if the number of elements of 2 sets are the same and not just the cardinal number, we call such sets as equal sets. Here, set A and set D are equal sets. One point to note is that all equal sets are equivalent sets, but all equivalent sets need not be equal. To represent an element E in the set V, we use the symbol epsilon. We say that element E belongs to set V. To show that an element T does not belong to set V, we use the symbol T does not belong to V, where the symbol epsilon is crossed using a slant. If there is no element in a set, we call it an empty set. Why don't you try searching for Fast Track TV in Amazon and Flipkart? You will not get any result, right? That's because Fast Track company doesn't produce TV. Again, can you create a set of odd numbers such that they are divisible by 2? You cannot. because no odd number is divisible by 2. These two are examples of an empty set. If we can create a new set using the elements of a set, we call the new set a subset. In this example, set A is a subset of set B, but set C is not a subset of B because element 13 is not in set B. It can be said that if all elements of set A are also elements of another set B, then A will be called subset of B. Now this will be written like this, and this is read as A is contained in B. If A is not a subset of B, we write and read as A is not contained in B. Now you may wonder whether set A is a subset of set A itself, and for this we shall recall the definition of a set. Now since every element of A are also present in the set A, then A will be called the subset of itself. Now that A is a subset of itself, it is essential to differentiate the other subsets of A. If we can find a set with at least one element lesser than A, those sets will be called a proper subset of A. You will see that the symbol denoting proper subset will be different from a subset. As set A is a subset of set B will be called the superset of A. Now, can an empty set be a subset of set A? To understand this, assume that you have a 10 rupees note and a 20 rupees note. If you give the two notes to your friend, you will not have anything left with you, right? So, you not only had those two notes, but it was also empty. So, you'll see that empty set is also a subset of a set. If there is no element common between two sets, we call those sets disjoint sets. A set will be called a universal set if it contains all possible values as elements, depending on the conditions given in the problem. For example, consider a set of square, pentagon and triangle. Then universal set of this set will be set of all polygons. Now, if you have the universal set to be the set of all integers, then its subsets will be set of prime numbers, set of even numbers, set of odd numbers, and the like. Consider a universal set of all real numbers. Then the set of all rational numbers will be its subset. Now you might wonder why Q is used to denote the set of all rational numbers, because symbol R is already used for real numbers, and also as rational numbers are nothing but the quotient we get when we divide two integers, and so Q is used to denote the set of all rational numbers. As Q is a subset of R, complement of Q will be set R minus set Q, which is nothing but set of all irrational numbers. Finally, the set containing all possible subsets of a set will be called a power set. For example, if a set contains 1 and 2, then its power set will be empty set, set containing 1, set containing 2, and set containing 1 and 2. And so, in this video, we checked out set notations and also the different types of sets. In the next video, we will learn about set builder form and roster form in detail.